Well, good morning. My name is Lorenz. I'm the retired CEO of an automation integration company called Aceta. And before that, I was president of Ellison Technologies, the Midwest region. So I've been involved in the CNC world virtually all my career, and the industrial automation piece was a sidecar to that most of that time. So we're going to take about 45 minutes and talk a little bit about Industry 4.0 and specifically what small to mid-sized manufacturers should be considering now. I mean, like right now. The stakes are high. This is a winner-take-all scenario 10 years from now, and the companies that don't adapt will not be around in 10 years from now. So the stakes are high and it's pretty important. Before we get started, it's one of my favorite quotes. Future's here's just not evenly distributed. I took both these pictures. The picture on the right, I took at Fanuc Robotics at one of their facilities. Fanuc uses robots to make their robots. The thing you might notice in that picture on the right, there's no people in that picture. On the left, that's in John Deere, Horicon. Those pictures were taken 3 months apart. So today we're going to talk about Industry 4.0, but specifically I'm going to touch on 4 items: robotic automation, the digital ecosystem on your shop floor, and then some fun with artificial intelligence and augmented reality. So Industry 4.0, what is it? A lot of people talk about it. Here's kind of the whole group of things that it could be, from big data to AI to virtual reality, cloud-based computing. We're just going to talk about the 4 things that I mentioned, but when you talk about AI, this is kind of the big broad brush of what AI is. But before we get into that, there's some assumptions that we've got to really think about and consider when we look at business planning for the next really 5 years or decade. And the first is, we know that talent is going to be in short supply. I was at a meeting with the president of WCTC, the Waukesha Technical College, 2 weeks ago, and he said his prediction is we're going to say, remember how easy it was to hire people in 2021. That's a scary thought, because as we all know, it ain't easy. More data on that in a minute. The automotive industry is going to be turned upside down. EVs are a major game changer in the supply chain of how we make cars. We're going to talk about that a little bit. This is pre-COVID. This is total unemployment. That's the red line. And the blue line is, I'm sorry, it's the other way around. Red line is unemployment. Blue line is available workers. I'll get that right. Job openings is blue. Unemployment is red. We were in trouble before COVID. And COVID exacerbated a lot of problems. I'm not going to talk a lot about COVID other than to say the digitization of our economy accelerated 10 years in 1 year of COVID. And that structurally is not going to go back. It's going to stay that way. This is the US population. This is live births starting from 2015 through, read that, through 2015. And you can see the red is, that's not showing up. The baby boomers is the red, Gen X, yellow is the millennials. That's who's working right now in our population, in our country. That's who's going to retire in the next 10 years, and that's who's going to come in the next 10 years. We have a net loss of 500,000 workers per year for the next decade. So when you think about hiring and the people you want to grow your company with, the parade of people, the talent coming in is getting smaller and smaller and smaller. And more recently, this is a similar chart, this is from the CDC, but to focus on just the last 5 years, we've dropped from 4 million live births to 3.4. Now, why does that matter? This is who we're going to hire to work in our companies in the next 20 years. There's going to be less people. Now, immigration will offset that. Getting an immigration policy might be a good first step, but we won't talk politics today. But the cold hard facts are, the population in the United States is getting smaller. Let's talk about Wisconsin. Most of you, I'm sure, are from Wisconsin. This is a projection that the WorkNet Wisconsin does. I'll just give you the highlights here. Right now, we have 3.1 million people actively working. If the economy grows at 3.5%, 4%. That'll go to 3.3. But if we drill into the numbers, and that's the circle on the right, we'll need about 22,000 people in the state of Wisconsin for growth, but we're going to need 76,000 to backfill for people that are retiring. Add those two together, that's 100,000 people in the state of Wisconsin that we're going to need through 28. Now let's look at who's in school today. So you can pull these numbers right off the DPI website. Right now, 12th graders full-time, we've got 65,000 12th graders full-time in the state of Wisconsin. But look how many first graders we have, 55,000. We've got a net difference of 10,000, almost 20% decline in our student population in our state right now. So remember we said we needed 76,000 just to replace workers from baby boomers retiring? We don't even have enough to do that, let alone handle the growth. And lastly, current job openings on the job info for Wisconsin is over 100,000. And this data, I just pulled this last month, so this is all very current. All right, disruption ahead. I'm going to exclude Rob Braun from this question. Does anybody know what that's a picture of? It's an internal combustion engine, right? So that you can see the block, the piston, conrod, and so forth. An internal combustion engine has 2,100 plus parts, typically. Transmission, exhaust, drive shaft, rear differential. You know what an EV has? That's a Tesla Model X. A couple motors, batteries, cooling system. There's 86 parts in the drivetrain. So if your customers are the automotive segment, or your customers' customers are the automotive segment, I'm telling you right now, there is a cataclysmic change coming in manufacturing around automotive. So you think about companies like Federal Mogul, Delphi, American Axle, their businesses are going to be completely upended as we go to EVs. So whether you agree or not that they're ecological, if you agree that they're better for the environment, none of that matters. Our government is hell-bent that we're all going to be driving electric cars. And when we do, the companies that make the parts that go into internal combustion engine cars will go away or reconfigure themselves. So I could spend an hour on this. That's probably enough. So net result, just thinking a few steps further, automobile supply chain, automobile mechanics. Right now we have 750,000 automobile mechanics in the United States. You don't need to be an automobile mechanic to rotate tires and put helium in them and change the wipers. Insurance companies for autonomous driving, when an autonomous car crashes, who's responsible? There's no legislation that outlines that. So insurance companies are at a loss. Our government doesn't know what to do because the technology is changing so fast. So there's some major disruption coming up. I'll just read you the highlights here. VW slashes 7,000 jobs to go to electric cars. CEO of Ford said it'll take about 20% of the labor force to build an electric car than it does to build an internal combustion engine car. So if you stop and think about the number of people that are employed in the automotive space, either assembling cars or in the supply chain, it's about 8 million. That number probably will drop to 3. Okay, enough on the disruption. Customers are buying differently. Customers are, post-COVID, have entirely new patterns of consumption. And again, I won't go into these in detail. The first one is just who's shopping on the internet. Blue was before, black is now. People are more willing to switch brands because it's easy. Think about when you go to Amazon. I'm sure everybody here shops on Amazon. I know I do. I'm just looking for one thing. It offers me 12 choices. So I don't really care about the brand. I'm looking for best delivery, value, maybe the best price. Well, companies are doing the same with you. And this is a key kind of starting point on Industry 4.0. Your customers are buying differently today and are going to buy even more differently tomorrow. They're going to look on the internet, they're going to price shop you like crazy, and the allegiance that you think you have, if you don't have a competitive differentiator to keep them as a customer, to keep that relationship sticky is a term we like to use, you're in deep trouble. So McKinsey, who's a consulting firm nationally, has done a fair amount of research on this, has talked about it, and they've said that this is a winner-take-all scenario, meaning the companies that adopt Industry 4.0, the companies that digitize their business and give their customers access to that information real time are the survivors, the winners. The ones that don't, the fast followers, if you survive, you won't enjoy any of the economic benefits because you'll be playing catch up the whole time. So I can't put it any more succinctly. Customers are buying differently. They're going to want a different experience, and this is both business and retail. And the companies that are out in front of that, providing customers what they want, the way they want, in terms of consuming the information, are the winners. And the ones that don't may not even survive. So, where do I start? It's why you're here. Everything starts with a plan. Now here's the best news under the heading Misery Loves Company. So BDO did a survey, and this is of manufacturers from $500 million to $1 billion, and said, where are you on your Industry 4.0 journey? And again, the screen's not very large enough, but you'll get it. This is 5% are implementing now. The rest are just planning. And even worse, the first one is they haven't really started planning. So even the big guys are behind the curve. They know they need to do it. So the message or deliverable here today is, it's not too late to start, but you need to start. So if there's anything you walk away from with today, it's this. I want you to think about in your annual business planning process to include a technology plan. The technology plan for your company that includes an overall adoption strategy, meaning, am I going to be on the bleeding edge? I'm going to buy the coolest stuff, the highest tech, as fast as I can get it? Or am I going to be kind of a laggard, or am I going to try to be in the sweet spot? I want to buy technology that's robust, is proven, and will change my quality for the better, reduce my costs, that sort of thing. Your employees. I work with a number of companies, and as they integrate automation, the number one thing that we put together is a public relations campaign or a PR campaign for how the robots are going to be implemented in their companies. Imagine if you're in a shop and you're just on the floor and robots start showing up and the management hasn't said anything about it. Well, that's threatening. That's disruptive. That's concerning. But if you've been meeting with management, they've said, we're going to keep this factory open. We're going to invest here. We're going to buy more CapEx, and we're going to spend money educating you as an employee base to become robot programmers, robot maintenance mechanics. We'll be able to pay you more money because you'll be more valuable to the company with this additional training. That's a much different scenario than the robots are here, oh my God, we're all going to get laid off. So the employee piece, well, it's maybe not intuitive in a technology plan, it's a key piece of it. And I mentioned the training, you've got to leverage a technical college system as fast as you can. They've all got very good robot programming, robot maintenance, and industrial automation programs. So if you're not talking to your local tech colleges, pick up the phone and make the phone call. It's important to be talking to them. I have customers, vendors, and stakeholders. I'll talk about them as just a single group. As you digitize what's happening in your company, meaning you're collecting data real time on your machine tools on the floor, you're going to create dashboards. I've got some examples of that here in a minute. But you can also make those dashboards available to your customers. And so this goes back to being sticky. If my strategy to my customer in a machine shop is, I'm going to be the cheapest one, I'm going to have the best delivery, I'm the nicest guy, I have great open houses, that's a strategy. I'm not sure I would advocate it particularly. But if your strategy is, I'm going to give my customers such great access to their data that they can see when their jobs are running, they can see which machines they're running on, they can see their quality data real time. Is that worth something to the end customer? You bet it is. It's worth a lot. And you can flip that pancake and do the other side to your vendors. You can show them what your production schedule is, and now you can start creating a real-time Kanban system of when they need to be shipping you your material for the next jobs. So Industry 4.0, like I said, we're going to talk about these 4 items. So the first one is automation. We're a little bit behind the curve as a country. Again, I'm not going to read this to you, it's too small. The first line is Singapore, forget them. Korea is the next line. This is robot density in manufacturing per 10,000 employees. So what does that mean? That's the number of robots in that country per 10,000 employees in manufacturing. So Korea is at 868. Germany is at 346. Denmark, Sweden. Here's the United States. We're 228. The good news, that's up from 186 where it was 5 years ago. So we are way behind most of the industrialized world. If this doesn't scare you, it should. This is the annual installations of industrial robots in the 15 largest markets in the world. You know what the top line is? It's China. And you'd say, well, wait a minute, that's counterintuitive. Why would China be buying more robots than the United States? They've got all that free labor, cheap labor. Wage inflation in China is running 25% per year on the factory floor. They are no longer the cheap place to manufacture. They're lower cost, but they're not the lowest cost. But more importantly, they've understood the benefits you get when you automate a process and that you can run it 24/7 and don't have to rely on people to be there. So there's China at 140,000 robots last year, Japan at 50,000, and then we're at 33. So just to scale that, the United States is buying 1/4 of the robots per year than China. So we're behind. One of the first things when I talk to people about considering robotic automation is when we think about how we manufacture today, we do it around the human form, right? It's two hands, it's stereo vision, we can hear, we can even taste if we need to, if something's going wrong. We're standing, we're bipedal. A robot isn't those things, it can be. And many times in my career, I would walk in, a customer would say, right over there, see that work area where those 4 people are? We want to put robots here. Can you put robots there? And the answer 99% of the time is, yeah, probably. But is that really what we want to do? Do we want to exactly try to mimic this human form of manufacturing? Or do we want to re-look at the process from the ground up and say, let's not build the process around a human, let's build the process around a machine. Maybe the machine has benefits. Maybe the machine doesn't have a lift restriction. Maybe it can bend over and lift heavier weights. Maybe it's faster. Maybe we can hang it from the ceiling. So those are things we kind of want to think about. So the second thing I encourage people to do is crawl before you walk, before you run. As you start your automation journey, material handling is where you want to start. Load, unload, end-of-line palletizing, parts inspection, where the robot is really just moving something in 3-dimensional, as opposed to a process. That's level 2. That's painting, that's sealing, that's welding. That's when the robot now has a responsibility to have a welding torch, a paint gun, a sealing gun, and now speeds and feeds matter. Robots do those things all day, every day. That's not a problem. But I wouldn't recommend starting there. I would start with material handling. Okay, some videos. This is a syringe manufacturer in Puerto Rico. And you'd say, Puerto Rico? Why Puerto Rico? Don't they have cheap labor? All the American medical manufacturers all have facilities in Puerto Rico because it's still a US territory, so it's governed by the FDA, so they can make things that are FDA approved in Puerto Rico at lower labor costs. Now, that doesn't mean they don't automate, but that's why it's Puerto Rico. This is a syringe manufacturer. They're making 18 syringes a minute that are fully inspected, fully tested, and fully proven. And they can make 6 different syringes with 0 changeover. So they'll stop the system, reload the raw material, and keep going. They initially started by trying to do what people were doing, assembling the syringes, pushing them together. Well, that required tactile sensing. They had to know there had to be force feedback, and they didn't want to do any of that. So when they tore it all and rebuilt it back up, the solution was, let's take advantage of the robots, their speed and dexterity, rather than try to copy what human form was doing. In my earlier slide, I showed the word cobots. For those of you not familiar with that, a cobot is a collaborative robot, or a robot that works side by side with people. This is at a BMW factory in Germany where the robots in this case Cobots, are working side by side with people, and they're inspecting the seams, the door seams, the hood seams, the trunk seams, to make sure they're in tolerance for the production of the cars. They record all that data and actually keep all that data. So if there's ever a problem, they know historically they've got the data to go back and look. But the point is here, robots are working side by side, shoulder to shoulder with people. These cobots tend to be able to, I should say tend, it's a requirement, that if they come in contact with any fixed object, they stop. You can push them back. You can actually make them back away from things. So they're quite safe from that perspective. But they don't, as you imagine, they're not real fast, they don't have a real high payload. But there's a place for cobots, but they're really just only today about 3.5% of the total industrial robot market. And here's a little snap of the future. This is Boston Dynamics' first commercial available robot. This is a robot, obviously it's not bolted to the ground. It uses vision. It scans the QR codes on the boxes, and then the work order comes down electronically and says, build the pallet of 5 of this, 6 of that, and 12 of this. And the robot uses AI then to determine the path, the stacking pattern, all of that. In the background, you can see a robot unpacking a pallet and doing the same. From a safety perspective, as you can imagine, this area is fenced in, but these robots are completely autonomous and program themselves. So when you think about a warehouse application and what you would need to do with people, this is a game changer relative to technology and speed. So, number one, robots. If you don't have them, if you're not thinking about them, I certainly encourage you to do that. The second is what I call the digital ecosystem, or the digitization of your ecosystem. And since we're at the manufacturing show, I'm going to talk about CNC machine tools. Real-time data availability is going to be required going forward, required by your customers. How you deliver that to them is your call. They're going to want traceability and trackability. They want 2D barcodes. They're going to want to know the history of every part that you made for them, so in case there's a problem, they can trace it back all the way to you, and which machine it was on, and in some cases, even the tooling that was used to manufacture the part. As a result, you're going to have real-time data dashboards for your customers. Well, that's great, but where the heck do you get the data? There's a company in New Berlin, Wisconsin, Pindell Global Precision. He's taken 10 of his CNC machines, mostly Tsugamis, and connected them through a company called Machine Metrics. Now, I don't work for Machine Metrics. I don't have any interest in their company, but I think it's a pretty smart way to deal with this issue. Gives them real-time status of every machine. The interface can be either hardwired, it can be Wi-Fi or 5G. The cost to Pindell, other than the $1,300 per machine cost that he had when he installed it, is $100 per month per machine. So this is how he's set up. He's got his CNCs. So like I said, some are Wi-Fi, some are Ethernet. But here's an example of the dashboards he gets. This can be on his laptop, on an iPad, on a phone, but he can drill into any machine of the 10 and look what's happening real time on the machine. He can get an aggregated view of the shop. He can see it by machine, but also, and here's kind of maybe the second takeaway, he has developed real-time dashboards for his customers. So his customers can only see their data. They can only see the parts that are running for them. But imagine what that's like now in your factory when you have that kind of connectivity to a supply chain, and if you want to make a change. Oh, hurricane, it's coming into Texas. We need to reconfigure. Generac's going to need a whole bunch more parts. You call your supply base. Well, you don't have to call them. You can see if they've run your parts and send them a note and say, nope, change the production schedule. I need these parts now. So just another couple of screenshots. So again, you have it on your phone, iPad, any tablet. And the connectivity piece, I'll talk just a little bit about 5G. That's all the buzz and the rage for your cell phones and AT&T and Verizon and all that. I don't care about any of that. My phone's fast enough. But what I do need is 5G technology to have my devices on my floor talk virtually real time. The latency with 5G now is negligible. It's non-material. So 5G, OSHA accepts 5G as a way for your products to communicate on the shop floor. Secondly, you're going to start to see 5G embedded in different things that you're going to buy. Conveyors, feeders, gauges, even cutting tools will have Wi-Fi or RF chips in them, and we'll be able to have tell you when they've expired or going to expire. One thing that always need to talk about is cybersecurity. So we just hooked 10 machines on the floor at Pindell. They're connected to the internet. That's great. Guess what? If you don't follow cybersecurity, you are a target for hackers. So this is my only slide on this. If you are not following the NIST standard, the SP 853, and don't know what that is, look it up and do everything you can to adopt it as fast as you can. Two software packages I highly recommend are both CloudStrike and Darktrace. They're both AI-based security packages. They watch your network, and as soon as they see something in your network going somewhere that they haven't gone before, it shuts it down. So it learns where people go and what's normal, and then if there's anything outside of normal, it shuts it down before it can even cause a problem. Okay. Artificial intelligence. How in the world are we going to use that for manufacturing? That's stuff we see on TV, games, Watson, all that stuff. AI is already being used for real-time optimization of production and planning. Again, I use the hurricane model. A company like Generac uses AI to determine how they're going to reconfigure their production, and additionally what's in their warehouses if there's a hurricane coming to Florida versus Texas as an example. Using AI to look at machinery performance. Think about in a CNC program how much dead time you have as we travel back up, index a turret, and come back down. AI can be used to optimize CNC programs pretty quickly. And so a couple of examples of how AI works. So if you look at this, it's kind of a fun example. Is it a puppy or a muffin? And you got to look quick and you got to answer. And the answer is both. But human accuracy on that is 97%. AI is 98%. But the human, after 3 hours, is 92%. So the point is, you want to use AI to do these menial kind of tasks that are repetitive, that a person either would have a high error rate if they kept doing it, or just wouldn't even do it at all. And what I'm talking about is looking through data. Again, back there, I use our Pindell precision. He looks at, as an example, the scrap rate, the supplier of the material, the tooling, and he uses AI to then look at, is there a correlation between a particular job that runs well on this machine and not well on that machine? And what are the drivers? Was it the material? Was it the tooling? Was it the vendor that I got the material from? On a more serious maybe application, AI to determine skin cancer. So this Watson is used pretty heavily in oncology. So the question is it cancer or non-cancer? So they did a test, 100,000 patient images. Doctors were right 86% of the time. Accuracy rate for AI was 95%. But when the doctors took the AI results and used it to make their diagnosis, they went to 98%, and that's the takeaway. People say, worry, AI is going to take away all our white-collar jobs. No, it's not. What AI is going to do is the data analytics. In the banking industry, they're using AI now to do all the credit work, not to do the final analysis to determine do we loan the money or not. They use AI to collect all the data and package it and then make recommendations. So the point is, AI is another tool in the toolbox, arrow in the quiver, if you will, for looking at your manufacturing data and finding ways to improve efficiency, improve quality, and even pricing. So where do I start? This is a couple examples. Google and Amazon have made their AI software available for free on the internet. But more and more companies are starting to crop up. Accenture, Hewlett-Packard, and C3 AI are companies that you can hire to begin looking at your data. So this is step 3. You got to collect the data first, take a year to do that, maybe start to play with it a little bit, have one of your engineers. If you can program in Python, you can program this AI software, and then find a consultant who can really dig in for you. couple comments about data. You can collect data via spreadsheets, post, or you can do it with sensors in real time. But one thing you got to be really careful of is what I call causation versus correlation. AI was used, and they looked at a whole bunch of data sets and said, what causes lung cancer? And AI came back and said, cigarette lighters cause lung cancer. Well, it's not wrong, but it's really not right either. But that was more correlation than causation. So think about your data sets and what you're using, and certainly question the data when AI comes back and gives you some analysis. And there's a lot of data that you have access to. You can pull unemployment records. You can pull NAICS code data for your industry and look at performance and those types of things. But you have to remember, how clean's the data? Does the data have a bias? There's a company up in central Wisconsin that used AI to get more resumes because they need more candidates, but they found that the resumes they got were not reflective of who they wanted to hire, but were reflective of the people that already worked there. And when they looked at why, well, guess what they did? They fed the resumes of all the people that worked there and said, hire more people like this. AI did exactly what it was asked to do. It wasn't really what they wanted, but that was what they was told. So think about how clean is the data, and does your data have a bias? Next, think a little bit about your products. And is there Wi-Fi enabled technology that you could or should be putting in your products? Things as simple as a sump pump now are Wi-Fi enabled. Your sump pump can tell you when it ran last, when it's running, the temperature it's running at, all reporting to your phone. Water softeners, same thing, and even are connected back to the manufacturer or the distributor, and will call for salt when it needs salt automatically, and it's an on-demand subscription service. I mentioned Generac a couple times. They're leading the way here. If you buy a Generac generator, it's Wi-Fi enabled. You can start it. You can see when it ran last, when it requires maintenance. All those kind of things are now standard on that product. So the last one we're going to talk about is augmented intelligence, not augmented reality. We've all seen augmented toys and VR games and that sort of thing. These are some real type applications that are being used today. First one is training new employees. This product is from Microsoft. It's called HoloLens 2. It's a heads-up display. And in this case, they brought in a new employee. She's going to her job is to put a fuel pump on this engine. And what we're seeing is what she sees in the heads-up display. It's telling her where the parts are, the steps to follow to put the fuel pump on, the torque wrench and the spec she's supposed to torque the bolts to. If she's not sure, she can pull up a video, and the video will show her the next step. And lastly, it gives management complete analytics of all her motion, all her time, what she made, what the production was, and what the quality was against that. So when you hire a new employee, rather than putting them in a 2-week training program, maybe training is half a day, and then you're on the floor with a product like HoloLens 2. HoloLens 2 is $3,800 for the product. The bugger is the software. You got to write all the screens, you got to capture the videos, and so forth. There's a company here in Milwaukee, actually in Brookfield, called Owner's Edge. They have an affiliate company called Impeligo. Impeligo has a competitive product, HoloLens 2, and in the machine tool world, I think everybody's familiar with Trump, the laser folks, press brakes, and so forth. Trump now offers as an option, not HoloLens 2, a different product, but very similar, for $2,000, and it has reduced their service calls by 80%. Because the customers put on the glasses, go out to the machine and troubleshoot it with tech support live, seeing real time what the video is, and tells them what to do. So a similar example of that, waiting for factory service, this is HoloLens's example. This is a horizontal machining center. Can't get the service tech there on an airplane, can't be there tomorrow, it doesn't matter. So you take one of your service technicians, she puts on the glasses, boots it up, calls tech support, who could be in another country, could be down the road, doesn't matter. And before Zoom, before COVID, this was like kind of shocking to people. Now because we do Zoom, oh yeah, of course you could do this. So the point is, she goes through the instruction set. She's got the drawings. She's got 3D stuff. The only caveat here is the woman on the other end tells her to stick her hand in a live control cabinet. I do not recommend that. You want to shut the power off before you stick your hand inside a live cabinet, but it's Microsoft, so I guess they can do what they want. But the point is not to be missed. This is a game changer for industrial service. Are there times we got to put somebody in a plane? Absolutely. But how many times is it something small, something simple that a person with good mechanical knowledge, with the right instruction real time, can go and fix a machine? So that $2,000 option on the Trump pays for itself in spades. Okay, so what should I be doing now? I encourage everybody, of course, to have a business plan, and ideally a 5-year business plan, but I want to make sure that you include a 5-year technology plan. And in that plan, all your work centers, so that's a fancy word for machine tools, your production equipment on the floor, are all connected real time for data analytics. You've built customer dashboards, and you can customize them to them. That's no problem. You want to begin to adopt augmented reality tools either with your vendors or your customers, depending on your product. And here's where the rubber meets the road. Companies that get this right will target a 40% increase in productivity in their factories by using AI and technology by 2030. And just to kind of show you that I'm not too crazy, this was out of Forbes actually a couple of years ago. Projections by 2035, AI technologies have the potential to increase productivity by 40% or more in manufacturing. So the point is, we go all the way back to my first few slides. There's not more people coming. We all want to grow our businesses. In the next 10 years, to grow your business by 40% is only 4% a year, using simple math. That doesn't seem like a lot. So how do you grow your businesses 40% with no additional people? Well, I hopefully just gave you a few suggestions of where to start. So that is my time for the presentation. We can go to Q&A, and I'm happy to answer questions as long as people have them. And I'll repeat them so everybody can hear it just in case. It's a great question. So the question is, with the 5-year technology plan, who should be leading that? Who should be driving that? Should it be top management? Should it be mid or baseline engineers? The answer is it's right from the top, from the CEO, but at a 30,000 foot level. So the CEO kind of sets the tone of, we're going to be absolute leaders in technology. We want to take risk. We want to always be first, like what I call the bleeding edge of technology. And then the CEO, he or she then pushes that down through the organization to say, those are your marching orders. So really down to the engineer level, they'll do probably a lot of the data collection and to rebuild the plan back up, but it really starts at the top. Yeah, so the question is, Industry 4.0 and IoT, are you better to kind of build your own, kind of bootstrap, or are you better off to work with outside consultants? Today, right now, my inclination is bootstrap it, and here's why. This is in such its infancy relative to the consultant side of the business. I mentioned Hewlett-Packard and C3 AI. They've only been in business in this segment less than a year, or maybe Hewlett-Packard's been 2 years. I think ultimately you end there, but I think you don't want to spend $1 million on a failed project. And one of the questions I ask people early on is, how much did you spend and what was the ROI? And the big guys that were first don't have real good answers for that. It was more, well, yeah, we just thought we should do it. It was the right thing to do. Well, that's horse crap. I mean, we're business people. Everything's got to have a good return on investment or you shouldn't do it. So my direction is start small. Do the machine metrics. $1,300 a machine, $100 a month per machine. That's not expensive. And Bill would say it's worth $100,000 a year to him now, just in having that data. He talks about his production planning meetings. Those of you in here that were in production planning meetings, what's the first thing that you say? Well, what do we make? What do we make today, this week? What have we made so far for the month? Well, that's off the table because everybody already knows. Production planning is looking forward. Well, what are we going to make? So every investment should stand on its own, and so I encourage people to start small. Start with $1,000 projects, $5,000 projects. Don't spend $1 million until you're ready. And if you've done 4 or 5 smaller projects, then you're more educated to deal with a consultant and to give them really better direction.